This next set of slides addresses the California Plumbing Code Chapters 8 for indirect wastes and Chapter 9, which addresses vents. An indirect waste is a discharge or a waste line from a piece of equipment where an air gap or an air break is used as a backflow prevention device in the waste line. So generally speaking, whenever you see an air gap or an air break, then you're rest assured that that is an indirect waste line. Now there are minimum requirements for an air gap. The absolute minimum requirement for an air gap is a 1-inch air gap space, which is maintained and it's unobstructed through free atmosphere from the point of discharge to the flood level rim of the receptor that's receiving the indirect waste. It's important to distinguish the difference between an air gap, which is shown on the left-hand side of this slide, and an air break. There is a major difference between the two in that with an air gap, as is depicted here with a 1-inch minimum airspace, absolutely unobstructed in the free atmosphere, is always going to permit the indirect waste line to drain. It's never going to be plugged up, and it's never going to come in contact with any kind of additional waste. It's always going to be able to flow. So the indirect waste line will never back up into the machinery or the equipment from where the waste is being discharged from. Conversely, the air break, which is depicted on the right-hand side, shows a situation where if that floor sink became plugged and started filling with water, then it wouldn't take long before that water was actually touching the discharge end of the indirect waste line, and in fact providing additional contamination to that waste line, which may then have the possibility of migrating up into the indirect waste line and back into the equipment that is feeding it. So it's important to understand the difference between an air gap and an air break. Even though both of them are an acceptable method for indirect waste, the designers will determine which one of these methods is required to be installed at any given indirect waste line. Section 803 of the California Plumbing Code identifies some additional requirements for indirect waste piping, specifically the requirements for venting or trapping. And the venting or trapping requirements of indirect waste piping depends on the length of the actual indirect waste piping. If the piping is less than 5 feet long, there is no trap required and no venting required. If the piping is between 5 feet and 15 feet long, then the indirect waste piping has got to at least have a trap, but it's not required to be vented. If the piping is 15 feet long or longer, then the piping is required to be vented. And another important factor about the venting of an indirect waste piping is the fact that it cannot or is not permitted to be vented to the sewer connected vent. Additionally, the indirect waste piping itself must be greater than or equal to the same diameter as the drain outlet or the tailpiece of the fixture or appliance or equipment that it serves. Now there are some exceptions to that, but we're not going to get into that. Section 804 identifies indirect waste receptor requirements. Generally, these are considered fixtures. These have to be approved for the use. They must prevent splashing, and they have to prevent flooding, and they must remain readily accessible for inspection and cleaning. And this is important because, as we remember, readily accessible implies, or actually is defined as, being accessible without having to remove anything to access the receptor itself. This slide depicts a couple of sketches for a couple of scenarios for indirect waste piping. One of them shows a length of piping that is longer than 5 feet, which requires a trap, which is described there. Another one shows a length of indirect waste piping that is less than 5 feet and obviously does not have a trap and does not require a trap. This slide shows a couple of photographs of what were originally designed and required to be indirect waste pipings with air gaps. However, the air gaps have been defeated by a couple of accessories that were installed. The one on the left shows a cone. It's basically a splash cone. However, the addition of this splash cone, even though it may have been required as a convenience, certainly negates the ability of the indirect waste piping to maintain a 1-inch minimum air gap. So it no longer has an air gap. It is now considered an air break. The photo on the right shows something very similar because the same conflict arises where the discharge from the indirect waste piping is now not discharging through free atmosphere. It's actually obstructed from the free atmosphere by the curb and also by another splash screen or splash guard that appears to have been installed above the floor drain grate itself. Chapter 811 addresses chemical wastes, and we briefly discussed this during our discussion about Chapter 4, relating to an image of an emergency eye wash and emergency shower, and the fact that there was no drain associated with that installation. The specific concern about chemical or industrial waste is that the discharge may actually damage the sewer system, and it may actually detrimentally affect sewage treatment plant or contaminate surfaces or subsurface waters. So the plans and specifications are certainly going to identify any special materials that are required in construction of the chemical waste system. And we see these sometimes in laboratory settings, in schoolrooms, where there's a possibility that acids or other corrosive chemicals may be used during classroom experiences. So obviously very special care has got to be taken with the design and also with the installation of these systems, and the product inspector is going to want to be sure to carefully review the plans to make sure that both chemical waste lines and the vent lines do not intersect any of the other waste or vent systems in the building. They've got to exist completely separate from the existing building sewer system. Obviously, the materials have got to be spec'd out so that they will stand up to the abuse and the corrosive nature of the chemicals that are anticipated being discharged into the lines. And again, this will all be drawn on the plans and also specifically spec'd out in the specifications for the materials requirements. Section 814 discusses the requirements for condensate and overflow water from air conditioners or similar equipment, and the fact that these particular indirect wastes must discharge into an approved plumbing fixture or disposal area. They have to be indirectly waste piped. The waste pipe has got to slope 1-inch minimum, or excuse me, 1/8 inch minimum per foot. The pipe diameter must comply with Table 814.3. It's acceptable that these discharge via an air gap or an air break into the plumbing fixture, and that these must be piped to a properly trapped and vented receptor, a dry well, a leach pit, or the tailpiece of a fixture. However, they are no longer permitted and have not been permitted for many code cycles to discharge over a public way. In the old days, they used to call these tattletales, and one of the reasons why it was acceptable to have these indirect waste outlets piped into an area that may actually be over a doorway or close to a doorway was so that maintenance personnel could monitor to make sure that these discharges were still free flowing. However, that practice has been abandoned for many code cycles, and we're not going to see those. This particular section of code identifies the more strict requirements for the discharge of these types of equipment. It's also important to understand that it is never acceptable for any type of AC overflow water or condensate to discharge into the storm drain. It is acceptable that it discharges into the building drainage, however. Okay, now we're going to start discussing Chapter 9, which addresses venting. Vents are required for each plumbing fixture trap. It's a very important understanding to have, that the whole reason for vents is to make sure that all of the associated traps located within the building drainage system remain free flowing. And of course, the reason for these traps is that the water seal located inside the trap makes sure that no noxious flammable gases are able to translate back through the sewer piping into the occupied areas of a dwelling. So the trap itself has got to remain full of water. The vent makes sure that it remains free flowing, and it protects against actual siphonage, back pressure, and encourages the air circulation in the drainage system. There are situations where vents are not required, and some vents may actually be omitted on an interceptor with certain provisions. And again, these are rare occasions, and the plans will show these situations. Traps that serve sinks for bars or soda fountains and counters that are actually impossible to vent, sometimes these are called island fixtures, may have their vents omitted, and in those cases an indirect waste system is required to be installed. And we'll discuss a little bit more about this in section 909. Some of the common ways for a trap to lose its seal is siphonage, leakage, aspiration, momentum, oscillation, back pressure, evaporation, and capillary attraction. And all of these particular events are what is trying to be mitigated or avoided by making sure that each of the traps contain water and have water in them that is free flowing and unobstructed with the introduction and the openness of the vent piping itself. The materials that are required to be used for vent piping are the same as the materials permitted to be used for waste piping, and you can refer to table 1701.1 and also now with the new table that's been added to the CPC 1701.2 in the event that alternate materials or methods for construction have been approved by the design team. Again, this is a similar new amendment where any ABS or PVC drain, waste, and vent piping must be installed in accordance with the fire stop protection requirements in CBC. This is a new amendment. We've discussed this once before, and this is going to continue to show itself in a few of these chapters. The size of vents are determined by the total number of fixture units. However, the minimum size for vent piping is 1 1/4 inch, and vent piping sizes are also identified in Table 703.2. However, rest assured that the design team is going to identify what the required pipe sizes are. So all that needs to be done is to, again, inspect based on the approved documents. For vent pipe grades and connections, the vent pipe has got to be graded at least level or back towards the actual drainage pipe that it serves. There can be no sags and no drops in the vent piping. Again, the idea is that the vent serves such a critical purpose in maintaining the trap seal that it cannot be obstructed for any reason. Vents are also required to rise vertically a minimum of 6 inches above the flood rim of a fixture before it offsets horizontally, and all vents are supposed to extend undiminished in size through the roof and above the roof, all the way to their termination. All vents are required to extend through a flashing at the roof line or where their termination is from the building, and are required to terminate a minimum of 6 inches above the roof, and also 12 inches minimum from any vertical surface. Vent lines are required to terminate 10 feet minimum from or 3 feet minimum above an openable window or an air intake or a door, etc. A new amendment, one that we've discussed previously, has to deal with ABS and PVC piping that's used as vents, which extends through the roof and is exposed to sunlight. These particular sections of the piping that are exposed to sunlight must be protected by a water-based synthetic paint. The design team also has options for other methods to use to protect these pipes from ultraviolet degradation. And if you see something besides a water-based synthetic paint, you can defer to one of the previous chapters that also permitted 1.02 millimeter tape covering. But again, these details are going to be approved by the design professionals and clarified and detailed on the plans. This slide simply shows a visual representation of the minimum vent terminations that are required, and it's basically a visual recap of the dimensions that we just discussed. Basically a 6-inch minimum above the roof, 12-inch minimum from vertical surfaces, and also either 10 feet or 3 feet minimum distances from either from or above operable windows, doors, etc. Chapter 908.2 discusses the possibility for horizontal wet venting for a bathroom group. We see these sometimes in schools, and it's worth addressing here. The requirements are that 1 or 2 vented lavies may serve as the wet vent for the water closet. The sizing for the piping of the wet vent itself has got to be 2 inches minimum for 4 drainage fixture units, or 3 inches minimum for 5 drainage fixture units or more. The trap arm length and the trap size has got to comply with Chapter 10, and we'll be discussing that in the next section of slides in more detail. The water closet is required to be downstream of the trap arm connection to the horizontal wet vent, and only fixtures within the bathroom group are permitted to be connected to a wet vented horizontal branch. Here's a simple picture that shows in better detail visually what a wet vented system will actually look like. This is basically a bathroom group where you've got a water closet, a lavvy, and a tub. And obviously you can see there's only one 2-inch vent for this entire group. This is the only vent that's drawn in this isometric. And you can see this one vent is serving this tub, this lavatory, and also this water closet. So the important distinction to make is that actual drain lines, this section of drain line here and this section of drain line is actually serving as the vent for the water closet. And also the tub itself is receiving its venting from this section of the drain line from the lavvy. So this is just a visual representation of what we were discussing on the previous slide for wet venting a bathroom group.